Today, I'm here to explain about the question, what is the minimum and maximum number of intersections of the x-axis for the following polynomial function? To solve this question, you need to understand the meaning of intersections of the x-axis. Do you remember that? For the last video, I explained about it, but let me explain it again. Intersections of the x-axis is the point where the graph crosses x-axis, like that. These are intersections of the x-axis. So in this question, you need to find how many intersections of the x-axis could these functions have. Okay? But before working on the question, let me briefly sketch the graph of y equals x squared. The graph y equals x squared is like this. Oops. And for the last chapter, I explained about transformations of graphs. So it can move, it can translate, it can reflect, it can compress, it can expand. But anyway, what I wanted to say is, if the polynomial of function's degree is 2, the graph has one term, like this. On the other hand, if the degree of the function is 3, it has 2 terms, 1, 2. Okay? Then maybe probably you can take a guess. What about the graph of the function which has degree of 4? Yes, it has 3 terms. 1, 2, 3. Like this. These are the graph of polynomials. Okay? Then let's back to the question. Number A, you have to find out the intersections of y equal negative to x to the power of 5 plus something. So how many terms does this function have? The degree of this function is 5, so it has 4 terms. Okay? 4 terms means if it starts from the top, 1, 2, 3, 4, like this. Then like I said, graph can be transformed, it can move, so it can be like this, or it can start from here to 1, 2, 3, 4, like this. But anyway, you have to find how many intersections of the x-axis could the graph have. So let's find the minimum intersections first. Like I sketched, if the graph starts from top, 1, 2, 3, 4. At least it needs to have 1 point of intersection. Even if it starts from down, 1, 2, 3, 4. It has at least 1. So the minimum intersections is 1. Okay? Then what about maximum intersections? If the graph turns around x-axis like this, 1, 2, 3, 4, it has maximum intersections, which is 1, 2, 3, 4, 5. This is maximum. 5. You got it? The next one, let's move to number B. Y equals 3x to the power 6 plus something. The degree of this function is 6, so it could have 5 terms. Okay, so let's find minimum intersections again. So let me start from top. 1, 2, 3, 4, 5. Actually, it's possible it doesn't have any intersections of x-axis, so which means minimum intersections is 0. Okay. And what are maximum intersections? If the graph has the turn x-axis, 1, 2, 3, 4, 5. So let me count it. 1, 2, 3, 4, 5, 6. You can have 6 intersections. That's how you count it. But actually, you can compare it with the function and the number of maximum intersections. If the degree of function is 6, maximum intersections is 6. If the degree is 5, maximum intersections is 5. So what about if the degree is, for example, the x to the power of 22, it could have maximum intersections of 22. Okay? And what are minimum intersections? If in the case of number A, it could have 1 minimal intersection. What if it's 3? If the degree is 3, y equals x to the power of 3, it has 2 terms, so 1, 2. So it needs at least 1 x intersection. This means if the degree is odd number, I mean 1, 3, 5, 7, 9, 11, it needs to have at least 1 x intersection. So minimum intersection is 1. But on the other hand, if degree is even number, like 2, 4, 6, 8, 10, the minimum intersections is 0. You can try, you can just briefly sketch, then you can make sure that